Good morning. Today we will be going over factoring special cases in this video lesson. Before I get into what it is that we're going to be learning today, I do just want to mention a couple of housekeeping items. You have a couple of assignments that are due today. Your spiral review for the week is due, and also the 7-6 enrichment activity that I gave you earlier this week to complete. That's due today as well. If you didn't finish either one of those things, if you finish this video a little bit early, you can always work on that. However, they are due today, so please make sure that they end up in the turn-in tray before you leave. The second piece of housekeeping that I want to make sure that you are aware of is when the Topic 7 test is going to be. I told you earlier this week, but I do want to remind you that the test is going to be next Wednesday. We've moved it up just so that we can get it done with. You do not have your quiz today. So we've taken the quiz out, we have moved that test up. With that said, we will have some time to review every concept from Topic 7 on Tuesday, so you'll have that opportunity. If you did want to do a little bit of review, just make sure that you're going back through your notes and looking at all of the different things that we've learned so far. Some of the concepts you can see on the table of contents are adding and subtracting polynomials, multiplying special cases, and then we got into the different types of factoring. So we talked about factoring by pulling out a common factor. We talked about how do we use the box method, the grouping method, various different methods to factor different types of trinomials. So today we are going to move on to the last topic, or concept in the entire topic of polynomials, which is factoring special cases. So just like we had a concept of multiplying special cases, this is when we are factoring them. I like to think about multiplying special cases and factoring special cases as essentially the same thing. One is combining certain binomials to create a special trinomial. Factoring is just taking it apart. So you're going to see a lot of the same things that you saw in lesson 7-3 today on our note taker. So with that said, we are going to move into our notes. If you have not yet glued this into your notebook, please make sure that you do. And then I've given it a title, Factoring Special Cases. We will go over the different types of special cases, how to factor them, and then you'll have a chance to do a little bit of practice on the following page. This will be at your own time. As we are going through this, you're more than welcome to stop, rewind, rewatch, whatever it is that you need to do in order to keep up with what it is that we're learning today. So with that said, let's go ahead and start with our very first special case. I'm going to zoom in here so you can see nice and easily the first type of special case that we are going to factor. And this is with the difference of squares. Now you'll notice at the top of this section, there is kind of a rule here, and we are going to use that rule to factor. A special case of when we're talking about difference of squares, you're going to see a binomial to start in which you are going to factor. I know that we've been factoring trinomials before. This binomial is special because it's just the first term squared minus the second term squared. So when I see a binomial like this, the result when I factor it is going to be whatever the square root of the first term is plus the square root of the second term times the square root of the first term again minus the square root of the second term again. So I'll show you what that looks like when we're talking about an actual binomial with numbers. I can see that this is going to be a difference of squares case because I have two terms in this binomial that are both perfect squares. And if I remember, a perfect square is something where I can find the square root of, and it's going to give me a integer or a whole number solution, okay? In this case, x squared, the square root of x squared is just x, and the square root of 9 is 3. So when I factor this, all I'm going to do is I'm going to take the square root of each of these. So square root of x squared is x, square root of 9 is 3, and those are now going to be my two terms. The only difference between the two binomials is that one is going to be addition, the other one is going to be subtraction. Ta-da, we've factored it. That's it. Now, when I have a binomial where the first term is not only just x squared, but it has a coefficient, what I'm looking for is that that coefficient also is a perfect square. So in this case, 4 is a perfect square. I know that I'm going to be able to factor it using difference of squares. The way I do that is I am going to look at the entire first term, and I'm going to find the square root of that term, and to do so, I would be finding the square root of 4 and the square root of x squared. When I do that, then I'm given that first term, the a term, which is 2x. Square root of 4 is 2, square root of x squared is x. The second term in the binomial is simple because 81, the square root of 81 is 9. So there's your second, your b term in this binomial. The second binomial, same thing, the only difference is you're subtracting. And that's it. That's how you use the difference of squares. Yes, you can use one of the other strategies that we've used before. So the last lesson that we talked about was talking about factoring ax squared plus bx plus c. You could use this method. The only difference is instead of it having this bx, b is 0. So we're looking at ax squared plus 0x plus c. And then you would find the factors of c that had a sum of 0. This rule right here just makes it a little easier, more quick to factor because we have this rule. The second special case that we're going to be looking at are these perfect square trinomials, and you'll see that there's two different rules. The only difference between this is that when I'm looking at the trinomial, a squared minus 2ab plus b squared and a squared plus 2ab plus b squared, one is subtracting, one is adding. And the difference is when you factor it, your two binomials are either being subtracted or they're being added. Now, more simply, I could say a minus b times a minus b is just a minus b squared. And I would actually say that this is the more accurate answer here when I'm factoring it. Okay? It does not mean that this is incorrect. I just would say that this answer is a little bit more concise. Okay, so I'm going to show you how we factor the perfect square trinomials, and we're going to start with example number 3. All right, the way that I'm going to look at this is, and to determine that this is indeed a perfect square trinomial, because I want to make sure that it is a perfect square trinomial before I start factoring it using that rule, is I'm going to look at the first term and the last term. And then I'm going to find essentially the square root of each of those terms. So the square root of the a squared term, and I'm just talking in terms of the way that it's represented here, would be x. The square root of the b squared term, or just b, would be 7. And then when I combine these, this middle term should be 2 times the first term times the last term. In that case, it would be 2 times x times 7, or 14x. So since that is indeed 2ab, we know that this is a perfect square trinomial. Now that I've identified it as a perfect square trinomial, I can simplify it real easily. This is an addition problem, so that means that we're using this second strategy. All I'm going to do is I'm going to take a and b, which I've already found earlier in the problem because that's how I decided this was a perfect square trinomial, which is x plus 7, and then I'm just going to square it. Done. So the hard part part is on this to make sure that it is a perfect square trinomial before you start using the rule. So you really have to look at the A term and the B term separately and then multiply that by 2, or the product of those by 2, to see if that works. So I'll show you again with the next one. We'll start with the first term, the A term. If I were to find the square root of that, of 9x squared, that's 3x. The B term, the square root of 25, is 5. If I were to multiply 2 times A times B, that would be 2 times 3x times 5. 2 times 3 is 6 times 5 is 30, giving me 30x. Perfect. I know that this is a perfect square trinomial. Now that I know it's a perfect square trinomial, all I'm going to do is take the A term that I already identified here and the B term, square it, and then since this is subtracting, I know that I'm going to subtract. Again, I know I did that pretty quickly, so if you need to go back over how I identified that it was a perfect square trinomial or how I came up with the factored form, please pause the video and rewind. Okay, you're going to have a couple of examples of that on your practice page, so I want to make sure you know how to do that. Okay, the last thing that I'm going to talk to you about is if there are 2 variables in one of these special factors. It's actually pretty straightforward, as well as possibly some ways to simplify. So the first thing that I'm going to work on where there are 2 variables, this one has an x squared and a y squared, is to use the difference of squares formula or shortcut to factor. The reason I'm using difference of squares is because I have 2 terms in a binomial which are both perfect squares. Now remember, when I have perfect squares, that means that the 16 has a perfect square root, the x is squared, this 225 has a perfect square root, and then y squared is a perfect square. So then to factor this, all I have to do is figure out, well, what's the square root of each of these? The square root of 16 is 4, the square root of x squared is x. The square root of 225 is 15. The square root of y squared is y. All I have to do is subtract the 2, make 1 plus, and then there we go. We have our 2 binomials. We've factored this completely. Okay? Keep in mind, all of the examples for difference of squares, remember difference means subtracting, so you always are going to be subtracting. If we're adding 2 perfect squares together, that does not mean that it is a difference of squares factorable binomial. You have to go about the process of finding what A, C is, figuring out what factors have the sum of B, and so on and so forth. So this is only when we're subtracting, okay? You'll see this one right here. It's the same type of thing. We have 2 variables. You might have noticed that this is not perfect squares, though. Now, we're going to approach this using one additional step, and this is the step that we had to use with a lot of our trinomials in the last lesson in order to make them more factorable. What I'm going to do is I'm going to find the greatest common factor of each of the terms. I'm going to pull that out, factor it out first, and then I'm going to use one of the strategies, either difference of squares or perfect square trinomials. I know it's probably going to be difference of squares because this is a binomial that I'm subtracting, so I'm going to be prepared to use that method. So the first thing I want to do is I want to find the greatest common factor of each of the terms. I know between 3 and 12, 3 is the greatest common factor, so I'm going to pull that out. Between the x cubed and the x squared, the greatest common factor is always going to be your lowest exponent. In that case, it's x here, so I'm going to pull an x out. And the same with the y's. The y is going to be what's in common I'm going to pull that out as well. What's left is 3 divided by 3 cancels out, x cubed divided by x is x squared, and y divided by y cancels out. And then for the second term, 12 divided by 3